Welcome to your deep dive. We are jumping straight into Module 6, Lesson 1, Decoding the Digital Future.
Yeah, this is a really essential part of the material.
It absolutely is. We're moving beyond just understanding the mechanics of virtualization. Now we're getting into the strategic thinking, the stuff you need to design truly effective cloud services.
Exactly.
So if you're out there planning or managing your organization's cloud journey, this deep dive is, well, it's your blueprint. It's about connecting these massive global trends directly to your own infrastructure strategy.
That's exactly right. Our core mission here isn't to just give you a list of, cool new technologies. It's really about being predictive.
Predictive, I like that.
We have to understand the macro trends. These are the powerful, sort of non-negotiable forces that are compelling every single business to digitize right now. And then what are the next-gen technologies that actually enable that?
Right.
Because you don't grasp these external pressures. You'll inevitably design an IT service that's obsolete before it even launches.
It's dead on arrival.
It is. We're here to look at the tectonic shifts that determine the ultimate success or failure of your entire cloud service planning effort.
Okay, so let's unpack this with a real focus. The central theme here, it's like the entire DNA of commerce has changed. It's all about how we deliver and consume things now.
Everything. Services, products, you name it.
They've all become intensely digital, immediate, and super personalized. So this isn't some theoretical discussion about buying faster storage.
Not at all.
It's about demanding that IT adopts a completely new mindset, a service-centric approach, what we call IT as a service, or IT.
Right.
We're here to anticipate the future demands of the business units, the lines of business, so that IT can finally adapt and serve as a true strategic partner instead of just being seen as a cost center.
And that word anticipation. Architectural flexibility, that is the key concept here. If your cloud architecture is rigid or complex or just slow to provision, it immediately becomes a bottleneck.
And we know what happens when there's a bottleneck.
We do. When the business perceives a bottleneck from internal IT, they go around you. They resort to shadow IT.
Bypassing all your hard work.
Exactly.
Yeah.
And they incur risk and cost and complexity completely outside of your control. So you have to design for the market, not just for the server room.
Okay, let's start with that big picture then. The major forces of disruption. We're seeing these powerful, almost combined forces that are fundamentally reshaping entire industries.
Oh, yeah.
I mean, everything from finance and healthcare to logistics and manufacturing, these aren't just minor market adjustments.
No, these are the core engines. They are what's behind the absolute need for rapid IT transformation.
So what's so fascinating here?
Well, it's that we aren't talking about a single disruptive technology. It's more of a mandatory nexus of change.
A nexus?
Yeah. You've got technological advances, pretty dramatic shifts in social behaviors, and this constant nagging demand for more business agility.
Yeah.
They're all combining at the same time.
And the source material highlights 4 of these that are, you say, inseparable.
That's right. Social, mobile analytics, and cloud. You probably heard the acronym SMAC.
SMAC, right. So that's the foundational disruption. It's the catalyst that created this demand environment that all new cloud architectures have to satisfy.
It is.
So we need to understand the architecture required to support SMOs. Can you walk us through the architectural fallout of these 4 things interacting?
Certainly. Let's start with the social component, the S. The explosion of social platforms and just digital connectivity in general, it impacts every single aspect of an organization.
You mean things like market feedback, customer service?
Market feedback, customer service, supply chain visibility. And all of this generates massive, and I mean massive, quantities of unstructured and semi-structured data.
Yeah.
Think billions of comments, images, videos.
And the way we access and interact with these social services and how we create all that data, it's almost universally through our phones and tablets. So that's the mobile component, the equity.
Precisely. Mobile means the data is being generated anywhere, at any time, and the expectation is for an instant response.
Which immediately dictates your architectural requirements.
It has to. We're not dealing with internal users on a stable corporate network anymore. We're dealing with millions of geographically dispersed endpoints, all demanding high availability and low latency.
So architecturally, what does that force you to do?
It forces a transition away from those old monolithic applications that were designed for, a desktop client. You have to move toward highly distributed, API-driven, microservices architectures that are specifically designed for mobile front ends.
Okay, I can see the connection now. So you have this high volume of dispersed connections from mobile, and that's combined with the immense, often chaotic stream of data from social, and that just puts the spotlight right on the AI analytics.
Exactly. That voluminous high-velocity data stream, what we often call big data,
Hmm.
it's completely useless unless you can process it immediately.
You need the analytics layer.
You need that layer to find the patterns, to profile customers, understand buying trends in real time, and, inform executive decision-making. Architecturally, this is probably the most demanding layer of the whole stack
Why is that?
because it requires moving away from traditional vertically scaled relational databases,
Hmm.
things like Oracle or SQL Server. They really struggle with unstructured data and horizontal scaling. You have to move towards horizontally scalable NoSQL structures and distributed file systems.
So now we're talking about platforms like Hadoop or Spark, or maybe specialized databases like MongoDB or Cassandra, right?
That's it.
Systems designed to scale out by just adding more commodity hardware, not scaling up by buying a bigger, more expensive server.
That is the architectural insight. In doing all of this, processing petabytes of data, supporting millions of mobile connections, managing social interactions, and achieving that instant elasticity, it all requires a scalable, flexible, and immediately available infrastructure.
Which finally is the cloud, the C.
That's the cloud. The cloud is the scalable platform that enables the entire loop to function effectively. Without elasticity and automation, the whole SMAC nexus just collapses under its own weight.
So the insight here for you, if you're planning cloud services, is this. SMAC doesn't just push you towards, say, using virtualization. It fundamentally changes the required database architecture. It changes the application design paradigm, the network load balancing strategy.
The entire stack.
The entire stack has to be redesigned from the ground up.
Absolutely. And this shift demands new delivery models that go way beyond just renting virtual machines, IaaS. The cloud, in this context, is so much more than just infrastructure. It's the framework for delivering platform as a service PaaS and software as a service SaaS.
And these models are really central to the disruption.
They are, because they offer developers and business users any place, anytime access to tools, to features, to applications, without them ever having to worry about the underlying operating systems or hardware.
I think we need to dwell on PaaS for a second there, especially in the context of application development. If businesses are under all this pressure to rapidly deploy mobile support for their employees and their customers, why is PaaS the answer? I mean, why can't they just use IaaS and run their own code?
That's a crucial distinction to make. Developing mobile applications for, a whole variety of heterogeneous devices, iOS, Android, different screen sizes, varying network quality. It is incredibly complicated and slow if you're in a pure IA environment.
So every new mobile app requires a ton of setup.
You have to set up databases, scale web servers, integrate with identity management, ensure you have a robust failover. It's a lot of plumbing.
And PaaS abstracts all of that complexity away.
It does. By offering services like, say, robust mobile development environments or API gateways, containers as a service like Kubernetes, or even specialized data platforms like Hadoop as a service or database as a service, IT can significantly accelerate a developer's velocity.
So the developer just focuses on the business logic.
Exactly, not the infrastructure plumbing. And this is the revolution that accelerates efficiency. It achieves that immediacy we talked about, and it redefines the future of work by making IT a proactive enabler.
So the agility that the SMAC nexus requires, it demands that these underlying IT transformation models, moving from managing assets to providing consumption-based services, the real essence of ITAT, they have to be implemented successfully.
Right.
Because if IT can't provide a PaaS environment in an hour, but some external vendor can, the business is just going to walk.
Correct. The pressure is immense. And the technological challenge is one thing, but the cultural and organizational pressure to move from being a cost center that historically says no because of risk or resource limits to a strategic business partner that says yes and delivers services instantly. That is what defines successful digitization.
SMAC is the market force, pushing IT to make that transformation.
Precisely. So if SMAC represents the foundational forces that necessitated the cloud and ITS models in the first place.
The first wave.
The first wave, yes. Then the next wave of innovation, the emerging trends that IT has to be planning for now, is often categorized under smart technologies.
Okay, another acronym.
Another one. It stands for sensors, mobility, and augmented humans, analytics, robotics, and thinking machines. These are the technologies that SMAC is enabling right now. and they have profound architectural implications.
This is where we start seeing the physical and digital worlds not just merge, but become functionally interdependent.
That's a great way to put it.
So let's dive into the sheer scale of this connected world, starting with sensors and the Internet of Things, or IoT.
Right. Sensors, which are the basis of IoT, are really intelligent objects. They're designed to constantly measure and communicate. The source material says they can see, hear, smell, taste, touch, locate, assess, and communicate.
So they turn previously disconnected physical environments into a massive data source.
A massive high-velocity data source. Think about a factory floor, a roadway, even a patient's body.
And when we talk about scale, I think a lot of us think of consumer wearables like a fitness tracker. But the source material really emphasizes the huge industrial push here.
It does, yes. The real monetary driver here is industrial. There is a massive multi-trillion-dollar drive by giants like GE, Cisco, EMC, IBM toward what they specifically call the industrial internet.
And what does that entail?
It's the recognition that connecting heavy machinery, logistics systems, utility infrastructure, commercial vehicles, it offers unprecedented operational efficiency.
Okay, here's where it gets really interesting for you, the cloud architect. What are the unique challenges that the industrial internet and this massive amount of sensor data pose to a traditional centralized cloud core?
Well, the primary challenge is the sheer volume and velocity of that data stream, and just as importantly, the latency required for you to get any actionable insights from it.
Give us an example.
Imagine millions of sensors on a single wind farm or an entire aircraft fleet, and they're all transmitting status updates every single millisecond. You can't just pipe all of that raw data back to a central data center for processing.
It's too slow.
It's too slow, and it's way too expensive in terms of network bandwidth. It's just not feasible.
So what's the solution?
This creates an absolute dependency on what we call edge computing or fog computing. The edge devices themselves, so the sensors or maybe some nearby gateways, they have to become intelligent.
They do the processing locally.
They do. They process the raw data right there on site, correlate events, and then they only send filtered or summarized or critically urgent data back to the central cloud core.
So the cloud model fundamentally changes. It's not just a centralized processing hub anymore. It's more of a highly distributed control plane that's managing a network of semi-autonomous processing units out at the perimeter.
That's it, exactly. And this means IT now has to design and manage two data planes, that central core and the new distributed edge data plane.
And I imagine that distributed architecture introduces a lot of new complexity.
It does. But the ultimate value proposition is real-time correlation and proactive optimization. Take our aircraft example from before.
Okay.
Analyzing data streaming from an aircraft engine in real time. If you detect a micro vibration that indicates a bearing is about to fail, you don't send the raw vibration data to the cloud.
The edge device handles it.
Right. The edge device processes that vibration data, determines there's an anomaly, and immediately sends a small alert to the central system to schedule maintenance. That could potentially save lives, and it definitely minimizes costly, unplanned downtime.
So that's the provider and safety value. What about on the consumer side? You know, the classic example of the connected refrigerator placing an automated order for milk. What's the hidden architectural challenge there?
Well, for consumers, the challenge really shifts to security and interoperability. That connected refrigerator example. Sure, it needs a low-latency connection to a fulfillment service, but the real headache for IT is managing the security vulnerability of millions of cheap, consumer-grade operating systems that are now connected directly to the central corporate cloud.
Right. These devices probably have poor patch management.
Exactly. Poor patch management, complex provisioning protocols. They become massive security liabilities that have to be isolated and managed through some really rigorous cloud security policies.
And the sources also mention a trend toward open source in this space.
Oh, absolutely. The fragmentation of vendors in the IoT space is just huge. You might have one vendor for the utility grid, another for the machinery, a third for the farm equipment.
So interoperability is a nightmare.
It can be. And this necessitates a big push toward open source solutions, protocols, operating systems, data formats to replace all those proprietary systems. It's vital. Your cloud architecture must be open and adaptable, capable of ingesting data from any source, regardless of its specific vendor protocol.
And security policies have to keep up.
They have to evolve rapidly to manage this new, highly distributed, and frankly, often insecure data environment.
Okay, let's transition now to 3D printing, or additive manufacturing. This seems to fundamentally change the production process itself, moving from subtractive sew, cutting or molding to additive, building layer by layer.
That's a good summary. Traditional manufacturing is often characterized by, significant material waste and lots of complex assembly steps. 3D printing just flips this on its head, and it offers massive efficiency gains. You design a digital blueprint, send it to a printer, and the printer builds the object.
So what are the concrete business benefits that end up putting pressure on the IT framework?
I'd say there are three main pressures. First is structural integrity and material science. The additive process lets you create internal structures and really complex geometries that are just impossible with traditional methods.
So you get stronger parts.
Stronger parts and the ability to combine new materials like metal alloys and plastics within the same print job. Second, efficiency. The process reduces waste significantly. The source material highlights that some aircraft builders, who traditionally waste up to 90% of their expensive raw material,
90%.
90%, they can minimize this waste dramatically with 3D printing, which saves huge operational costs and energy.
Those are clear cost and quality benefits. But I think the most critical IT driver, especially for how you design your cloud services, is the impact on the development lifecycle, the speed.
That is the core takeaway. 3D printing enables incredibly fast time to market. A prototype that might take you days or weeks with traditional machining can now be printed in a few hours.
Which enables true on-demand manufacturing.
It does. A part breaks in a remote location. You send the blueprint via the cloud, and the part is printed locally. No expensive logistics, no warehousing.
The implication for IT is crystal clear then. Your IT platform has to be agile enough to support this rapid pace of product development. If the manufacturing part takes 3 hours, but provisioning the VM or the database for the next design iteration takes 3 days, IT is the bottleneck.
And this introduces a concept you need to know called the digital twin. Every part, every single product line has a detailed, secure digital representation, the blueprint, and it's stored in the cloud.
And IT is responsible for managing these massive, highly sensitive repositories.
Exactly. These digital assets have to be version controlled, highly secure, and instantly accessible to engineers and remote manufacturing nodes all over the globe. This demands secure, low-latency cloud storage, probably object storage, and really robust identity management to make sure only authorized nodes can access and print copyrighted or sensitive blueprints.
So the pressure on IT isn't just about speed. It's about the security and version control of what is essentially your company's intellectual property, existing as a massive file in the cloud.
And this pushes IT toward offering sophisticated pay-as services for things like product lifecycle management or PLM, often using containerization to ensure consistency between the design, testing, and manufacturing environments.
Okay. Our next trend, augmented humans, sounds like the next logical step from mobile. It's about blurring the physical and digital worlds using wearable and embedded devices.
It's about connecting human life to the digital stream in a really deep way.
This goes far beyond just using a smartphone.
Oh, way beyond. This is about real-time, personalized integration. When you have technology that's used in conjunction with our physical senses, think sophisticated medical monitoring, smart glasses providing instructions to a factory worker, or even embedded chips, it changes how we live and work, and it generates vast streams of personal health information.
What are some of the most critical examples of this integration that directly influence cloud design?
Well, in critical care, we're seeing embedded chips that can monitor vital signs for high-risk patients. These devices track and chart data constantly, and the real-time delivery of this data, often to a remote specialist or an automated alert system, is essential for saving lives.
And on the consumer side?
On the consumer side, you have wearables, tracking exercise, sleep patterns, heart rate, the usual suspects.
The IT implication here seems colossal, especially considering how sensitive this data is. This is personal, intimate, real-time data from millions of unique users.
It's a direct and powerful driver for robust cloud service design. Specifically, it demands three things. One, massive scale and velocity. The cloud platform has to handle billions of constant small data packets.
Which is perfectly suited for things like event-driven architectures and serverless functions.
Exactly, where compute scales instantly in response to the data stream. Two, compliance. Because this is sensitive health data, the infrastructure must adhere rigidly to regional regulatory frameworks like IDPA in the US or GDPR in Europe.
So that dictates where the data can even be stored.
It does. It often forces you to use geographically localized cloud zones and rigorous encryption practices for data, both at rest and in transit. And third, you need real-time API management. The infrastructure requires highly sophisticated API gateways to manage the incoming stream from millions of unreliable, diverse wearable devices, ensuring data integrity and security validation right at the ingress point.
So augmented humans don't just ask for more storage, they mandate a fundamental shift in our security model and a complete rethinking of latency and regional compliance within the cloud architecture.
That's right.
We're designing architectures where a failure to deliver data instantly, well, it could literally mean a threat to someone's life.
Exactly. And this forces IT teams to adopt concepts like design for failure and high availability with extreme seriousness. It means ensuring multiple copies of the data are stored across different availability zones, guaranteeing that resilience.
Okay. Finally, let's discuss thinking machines. This covers robotics, cognitive computing, and artificial intelligence, or AI. This is where software starts to, well, think for itself.
And it has the highest computational cost of any of the smart trends we've talked about.
Let's start with robotics.
Robotics, while it's been around, is seeing rapid growth outside of those static automotive assembly lines. We see robots increasing productivity dramatically in logistics and warehousing. They're performing complex tasks like picking, scanning, and assembling products for delivery.
Which leads to profound changes in supply chain efficiency.
It does. And it requires IT to manage complex inventory systems and robotic control software that's constantly communicating with the central cloud.
But the real computational challenge comes in with cognitive computing and AI. This goes way beyond simple programmed automation.
It really does. This is all about algorithms that are self-improving through machine learning. The intelligence is created not just by the original human developer, but by the application itself as it processes massive data sets.
So the software learns, it adapts, it makes predictions.
Right. We see this in virtual assistants, complex fraud detection systems, and, most visibly, in self-driving cars.
And the fundamental business impact is that AI is changing how problems are solved. The software will soon be able to answer the question, why did this happen? Not just what happened.
By analyzing correlation across billions of data points, architecturally, this means you need massive, specialized compute capacity. AI training models require astronomical computational power. They often demand specialized hardware, like GPUs or dedicated TPUs.
So you can't run this efficiently on standard, general-purpose virtual machines.
You really can't, which means for IT planning, the consequence is you must be able to offer specialized infrastructure as a service. Maybe GPU as a service, using high-end hardware that's virtualized specifically for these parallel processing workloads.
And that's crucial for controlling cost.
Oh, it is. Training a state-of-the-art AI model can cost millions of dollars in compute time. So IT has to design an environment that lets data scientists rapidly provision and then decommission these specialized resources on demand. You can't be paying for expensive GPU hardware when it's just sitting idle.
And this all ties back to big data.
Absolutely. This dependency on big data solutions ensures that the organization can analyze customer buying trends and enhance business opportunities, but only if the infrastructure is elastic and standardized. If it isn't agile, standardized, and elastic, it simply cannot support the computational load required to train, deploy, and utilize these thinking machines.
So we've moved from basic operational costs to strategic compute investment.
That's the core takeaway from the whole SMART discussion. These technologies are interdependent. They all funnel massive, high-speed, highly distributed data streams into the cloud. They demand instant scalability, specialized compute resources, rigorous security, and robust service definition. They're the future, and IT has to build the road to support them today.
Okay, we've established these powerful trends, us may see, and the more granular technology drivers, SMART. But let's pivot back to you, the listener, and the daily reality of your role in the IT organization. So what does this entire landscape of disruption actually mean for how IT functions, how it plans services, and how it allocates its finite resources?
It means that IT can no longer focus solely on today's operational best practices. Just keeping the legacy email server running or applying patches.
The keeping the lights on mentality.
Exactly. IT has to pivot to understand these emerging trends because fundamentally, trends drive business strategies. Its role is shifting dramatically from being a technical maintainer to a strategic innovator who translates business goals into deployable services.
So let's define IT's objectives in this new digital age. What is IT trying to achieve now that the business landscape is fully digitized and moving at the speed of mobile?
Well, the source material identifies 4 core objectives that IT must now champion to be considered a true strategic business partner. These are the measurable goals that prove IT is contributing strategic value.
Okay, what's the first one?
First, Operational excellence. This is the baseline, the table stakes. IT must deliver better operational results by reducing enterprise costs wherever possible. In a cloud context, this means leveraging resource pooling for better efficiency and utilization, standardizing infrastructure, and automating processes to lower labor and maintenance costs. All core tenets of IT as a service.
Right. And number two.
Second, customer and partner engagement. IT must now directly create and deliver user-friendly applications and solutions designed to entice and retain customers and partners. This is that mobile and social component we talked about. IT has to design attractive, high-quality front-end services and robust API backends.
Third is product differentiation.
Yes. IT is no longer just a support function. It's critical in creating differentiated products and services. By embracing new technologies, like enabling a secure 3D printing pipeline or supporting a new AI analytics model that leads to an innovative product, IT directly drives revenue potential.
And finally, talent.
Finally, talent acquisition and retention. Being perceived as a cutting-edge entity, one that offers agile development environments like Payless and supports modern, efficient processes that helps you attract new, digitally savvy talent and engage your existing workforce. It helps you fight the war for talent.
This all sounds great strategically, but let me introduce a dose of reality here. If IT transforms into an internal service provider adopting this IT as a service model, aren't we just setting ourselves up to compete directly with giants like AWS or Azure? I mean, that's a fight we can't possibly win on price alone.
That is the single most important question that IT leadership has to answer, and you're absolutely right. You cannot win on commodity price. But ITS does not mean mimicking public cloud commodity offerings. It means focusing on internal value creation that the public cloud cannot easily provide.
So what's the differentiator?
Internal ITS wins on compliance, customization, and connection. You know your specific regulatory landscape, you know your internal risk tolerances, and you know the legacy systems that need integration. A public cloud provider offers raw compute. You offer a regulated, integrated, secured internal cloud service platform.
So your cost advantage comes from optimized utilization and avoiding things like expensive data egress charges.
Right. While your value advantage comes from providing dedicated service level agreements, SLAs, that are tailored to your specific business applications.
So the concept of ITERIS is more than just a tagline. It has real operational components that have to be implemented successfully. What does an IT organization need to design to truly become service-centric?
You need the machinery of service delivery. This really involves three critical components that translate the technical stuff into a tangible business experience. First, the service catalog.
The menu of what IT offers.
It's exactly the definitive list of IT offerings presented to the business in business language, not technical jargon. It defines what IT provides: a mobile development environment, a GPU compute instance, a database as a service with standardized costs, performance targets, and delivery times. It formalizes your offering.
Okay, what's next?
Second, consumption-based chargeback. IT has to stop allocating costs based on complicated fixed budgets or depreciating assets. Instead, the business unit pays only for what they consume, mirroring the utility model of the public cloud. This transparency drives accountability and ensures resources are used efficiently.
And third, you mentioned SLAs.
And third, define service level agreements. Every single service in that catalog must have guaranteed performance metrics: uptime, latency, responsiveness. This is how IT proves its value and its quality compared to external providers. If a business unit needs 99.999% uptime for the data from a critical care chip, ITS must be architected to meet and guarantee that level.
Which means IT has to anticipate the precise high-end needs of these smart technologies when they design their service framework. We're talking about planning for extreme high availability, handling petabyte-scale datasets, and being able to provision infrastructure instantly for big data analysis, whether that's a dupe as a service or specialized GPU environments.
And this infrastructure has to be inherently resilient. Remember that design for failure concept we see in cloud-native architectures. The infrastructure must be designed with the assumption that the underlying physical hardware can and will fail. A disk drive, a server, an entire rack.
But the application just keeps running.
The application continues to function uninterrupted because it has a distributed architecture supporting multiple instances and automated failover. That is a fundamental requirement imposed by the always-on nature of mobile and IoT data streams.
So the ultimate core takeaway here is that IT must transform from a technology-centric organization focused on assets to a service-centric organization focused on value delivery. That's how you become a true strategic business partner.
It is. IT needs to view itself as an internal business, responsible for cost, efficiency, and actively supporting the revenue potential of the entire enterprise. The traditional ways of doing business-long, monolithic processes, complex annual decision-making cycles, they are an absolute hindrance in the digitized, real-time environment driven by SMAC and SMART. ITAs, characterized by agility, standardization, and elasticity, is the necessary path forward to avoid organizational irrelevance.
Okay, let's wrap this up.
To summarize this deep dive, we have meticulously covered the macro forces, so SMAC, social, mobile, analytics, cloud, that initially disrupted every industry. And then we covered the subsequent, more granular technology trends, smart sensors, mobility, analytics, robotics, thinking machines, that are now driving businesses toward complete high-speed digitization.
And the critical realization for you in IT planning.
The critical realization is that your infrastructure plan must not be built for today. It has to be built for tomorrow, and it must be adaptable enough, leveraging IT's automation and orchestration to support these rapidly evolving forces.
Because the consequence is severe. If IT doesn't adapt to provide these services with competitive speed and quality, the business will simply use shadow IT or external public cloud providers who have adapted. And here's where it gets really interesting for your long-term transformation roadmap, specifically concerning governance.
Go on.
If a company is already transforming successfully using self-improving algorithms, thinking machines in its core product line, how does IT governance itself need to evolve? How can human policymakers and compliance officers possibly adapt internal governance, risk management, and compliance policies fast enough to keep pace with an intelligence that improves exponentially faster than human organizational structures can change? The software might be identifying risk and rewriting its own rules faster than your annual policy review cycle can even happen.
That is the ultimate challenge in planning for a fully autonomous digital future. The infrastructure may be ready, but the organization has to be ready too.
Something profound to mull over as you consider Module 6 and your next steps in planning for radical agility. Thank you for joining us for this deep dive.